Hello everyone, Mr. Fawcett here, and we are back for another geometry lesson. We're actually about to start a new unit today. We're going to be talking about parallel lines, transversals, and perpendicular lines. So let's jump right into it. We're going to get started with a little review from Algebra 1. You have a system of equations right here, and it's your choice. You can either solve them using substitution or the elimination method. So pause the video, take some time to use one of those methods to figure out the values for x and y, and then come back here and see how you did. Okay, so we don't have time to go over both methods. I am going to use substitution here. So the first thing I'm going to do is get one of my variables by itself. I'm going to use the second equation, and I'm just going to subtract y from both sides. So I'm going to get x is equal to -7 minus y. That gives me an expression for x that I can now substitute in for x in my first equation. So I'm going to get 2 times the quantity -7 minus y minus 4y is equal to 10. I'm going to distribute. So I get -14 minus 2y minus 4y is equal to 10. I'm going to combine my y's. I'm going to add 14 to both sides and divide both sides by -6. That's going to give me y is equal to -4. If I know y is equal to -4, I can then substitute that back into either of my equations. Again, we actually have 3 here because we made up a new one for the second one, so you can substitute it into any of the 3. And that shows me that x is equal to -7 minus -4. Remember, I'm substituting -4 for y. That gives me x is equal to -7 plus 4. So x is equal to -3. You can check your answers by substituting both the x's and the y's into both of the initial equations, just to make sure that both solutions work. All right, and now let's jump into the new material for today. So let's get rid of this. All right, we're going to start off with a little vocab. All right, so if it looks like the notes have sort of been erased or kind of there was something written on them before, that's because there was. My student copy off of my computer got deleted, so I had to take my answer key and do a little erasing and then try to upload it again as a blank copy. But didn't work out perfectly, so that's why it kind of looks like it's already been filled in. They should still function the same way though, just don't look as nice. But this is the only one that looks like that, so we should be okay. One other thing, there's one mistake up here. We need to add the line notation above these letters because we are talking about lines, so just make note of that. All right, on to the vocab. So when two parallel lines, AB and CD, and those are pictured off to the right, when they're intersected by another line EF, this line EF, we call this a transversal. Okay, it intersects both of the parallel lines. When this occurs, there are several angle relationships that are created, and these relationships may be things that you've heard of before. You may have worked with them before in your middle school math curriculum, depending on how far you got in your geometry units. So vocab may be new to you, may not be new to you, but we need to make sure all of us have a solid foundation because we're going to be using it a lot throughout this unit and throughout the rest of the year. So one of those relationships is what we call corresponding angles. These are angles that are in the same relative position. So same relative position. Okay, what this means is that if we break these angles up into 2 sets of 4, so we have a set of 4 up here and we have a set of 4 down here, and I'm just breaking them up based on the ones that are all surrounding the intersection points of the transversal and the parallel lines. If I pick an angle from either box, I'm going to pick angle 1. Okay, that's in the top left-hand corner of that upper set of angles, right? It's in the top left. So if I look at the bottom set, well, the angle that's in the top left there is angle 5. So angle 1 and angle 5 are a pair of corresponding angles. And there are, of course, some other examples here. If I look at angle 3, the angle that's in the same relative position down below is angle 7. So we could also say angle 3 and angle 7. And then, of course, there's angle 2 and angle 6, and 4 and angle 8. We're just not going to write down every possible example. But corresponding angles, angles that are in the same relative position. All right, now we have alternate interior angles. These are angles that are on the inside of the parallel lines, interior meaning inside, and they are on opposite sides of the transversal. We'll talk a little bit about what this means. So our transversal, right, is EF. And we have these two parallel lines, A, B, and C, D. So the angles have to be on the inside of the parallel lines. So they have to be inside here. So that eliminates angles 1, 2, 7, and 8. So let's pick one of the other angles that's inside. Let's pick angle 3. So alternate interior angles, they have to be on the inside, but they have to be on opposite sides of that transversal. So opposite sides of the transversal, meaning it can't be on the same side that 3 is. So we have angle 3 and angle 6 is the one that's going to be alternate interior to angle 3. And the reason we're not doing angle 3 and angle 4 is because we're taking one angle from this top section and one angle from this bottom section. So angle 3 and angle 6 are the only two angles that are both inside the parallel lines and on opposite sides of the transversal. If we start with angle 3. If we start with angle 4, right, then the only other angle that can be alternate interior to angle 4 is angle 5. We'll actually give those two arcs to show that they're different from 3 and 6. So we have two examples. We've got angle 3 and angle 6 and angle 4 and angle 5. So we have two sets of alternate interior angles. Again, use the name of the angles to help you out here, right? They're called alternate interior. Alternate meaning opposite, so opposite sides of that transversal, and interior meaning inside of the parallel line. So the name provides a little hint for you. Okay, let's get rid of some of this. Talk about consecutive or same side interior. You know what, I'm going to get rid of all of it so we have a fresh screen. So consecutive, also called same side interior angles, are angles that are on the inside of the parallel lines, or you can say interior, and they are on the same side of the transversal. So let's take a look. We've got two sections of angles. Let's look at angles that are on the inside. So I'm going to pick an angle on the inside of the parallel lines. I'm going to pick angle 4. And the angle that is on the same side of that transversal has to be angle 6. So angle 4 and angle 6 are on the inside of the parallel lines. They're inside, and they're on the same side of that transversal. They're both to the right side of line EF. All right, so let me make this a little bit more clear. Again, line EF, oops, it was on my eraser. So line EF is our transversal, and angles 4 and 6 are on the same side. They're both on the right side. Now you may be wondering, why am I using one arc for 4 and one arc for 6? That's just because we don't know that both of those angles are congruent. So with the alternate interior, those angles end up being congruent, which is something we'll talk about later. Same thing for corresponding. But for same side interior angles, they are not always congruent. So I don't want to put one arc there for both, because that would signify that they have the same measurement, and we don't know that. Okay, so examples are angle 4 and angle 6. And then we can come up with two others. We can do angle 3 and angle 5. Those are both same side or consecutive interior angles. You can use whichever word you want. You can either say consecutive interior angles or you can say same side. You just need to know that consecutive and same side mean the same thing. Okay, on to the next page. I'm going to have to draw this diagram again, just so we have it. Let's use a lighter color. That's my eraser. Still my eraser. There we go. Choose light green. We'll do 1, 2, 3, 4, 5, 6, 7, 8. All right, so alternate exterior angles. These are angles that are on the outside of the parallel lines. That's what exterior means. And on opposite sides of the parallel lines and on opposite sides of the transversal. So let's break that three-part definition down. They have to be on the outside of the parallel lines. So they have to be on this side or on this side. So let's pick an angle. Let's pick angle 1. So they have to be on opposite sides of the parallel lines. So that means I can't choose angle 2 because that's on the same side of the parallel lines. That would be on the top, just like angle 1. So I've got to either choose 7 or 8. But they also have to be on opposite sides of the transversal, so that eliminates 7. So angle 1 and angle 8 are alternate exterior angles. Angle 1 and angle 8. We also have two others. We have angle 2 and we have angle 7. Okay, so they have to be outside of the parallel lines, and they've got to be on alternate sides of that transversal, as well as one has to be on the top and one has to be on the bottom. Or, of course, I could draw my diagram like this, and then we'd have to think about left and right rather than top and bottom. But we'll get into plenty of examples later on. Last one is consecutive or same side exterior angles. So these are angles that are on the outside of the parallel lines. They're on opposite sides of the parallel lines, but they are on the same side of the transversal. So let's pick some here. Let's get rid of those. So if I choose angle 1 again, I need an angle that is on the outside of the parallel line, so either 2, 7, or 8, but it has to be on the opposite side that 1 is. So now we're only looking at 7 and 8. And it has to be on the same side of the transversal, so that eliminates angle 8. So I have angle 1 and angle 7. Okay, those would be consecutive or same side exterior angles. And then we could also do angle 2 and angle 8. Again, I'm doing color coordination here to help you understand those relationships. Okay, so those are the 5 different types of relationships that we're really going to hone in on, not only on this lesson, but we're going to use it for the rest of the unit. We're going to continue to use it in our proofs throughout the rest of the year. Before we start doing some practice problems, let's talk about this. Think about which of these types of angle pairs will be congruent. And I kind of gave you some hints along the way with the different types of arcs that I made, whether I gave them 1 arc or 2 arcs. Some of them will be congruent. Some of the angle pairs will be always be supplementary. So pause the video, see if you can write the 5 different types of angle relationships, put them either in the left-hand column or the right-hand column, depending on whether you think they're always congruent or whether they are always supplementary. All right, so I'm going to get rid of this. I'm going to make our box a little bigger. And I'm going to draw another diagram for us again. All right, so the first angle relationship, the corresponding angles, that would be like angle 1 and angle 5. We're not going to go through a proof for this. We're kind of just going to look at our diagram and think about whether we think they're congruent or supplementary. And these are going to be in the congruent column. So corresponding angles are always going to be congruent. Okay, the next one would be alternate interior. So alternate interior would be like angles, oh man, let's redo that real quick. Okay, alternate interior, oh, sorry, did I say alternate interior? Yes. That would be like angles 3 and angle 6. Those are also in the congruent column. So alternate interior. We then have same side or consecutive interior. So those would be like angles 3 and 5. And you'll notice those actually don't really look like they're the same. Angle 3 looks like it's an acute angle, less than 90, and angle 5 looks like it's more than 90. So for these, and again, we're not going to go through a proof, but they are not going to be congruent angles. However, they will always be supplementary. They will always add up to 180. So same side, and you can use SS as an abbreviation, same side interior angles. All right, then we have alternate exterior. That would be like angle 1 and angle 8. As you can see from the diagram, those look like they are congruent. They are going to be congruent every time. So alternate exterior. And then we have same side exterior or same side interior or same consecutive exterior. So that would be like angle 1 and angle 7. Really keep forgetting that I'm on my eraser, and then the whole thing just goes, well, we're going to use blue and red this time. A little frustrating, but that's okay. All right, so we have angle 1 and angle 7 for our consecutive exterior or a same side exterior. Again, you can kind of see that those don't look like they're congruent, and they're not. However, they are always going to be supplementary. So same side exterior angles those are always going to be supplementary rather than congruent. Take a look at the question below. It says, can you think of a scenario when two of the angles in the diagram above will be both congruent and supplementary? And then you can write your guess in the lines below. We're not going to cover this in the video, but think about this question. You can bring it to our discussion at a later time, and we can talk about when angles may be both congruent and supplementary, depending on how the parallel lines and the transversal are drawn. But let's go get into some practice. All right, so for these practice problems below, and this is going to apply to all the practice problems, not just numbers 1 and 2, 1 through 8, you are going to write down the angle relationships that are helping you set up an equation or helping you understand what the missing angle measurements are. Okay, again, we're not just doing the math, we're coming up with that explanation part, that justification part. When we're doing proofs, we still want to include that in these types of problems, even though we're not doing a formal 2-column proof. So not only are you going to give me your algebra, you're also going to give me your reasons for what's going on. So we're just going to do numbers 1, 3, and 5 in the video, so just 3 quick ones. Write down the angle relationship that helps you solve for the missing angle, and then show your algebraic work as well. So pause the video, try numbers 1, 3, and 5, and then come back here and see how you did. All right, so for number 1, we have two angles. We have angle question mark and angle measurement 110. These are alternate exterior angles. And this means that they are congruent. So if they're congruent, there's really not much work to do, right? If they're congruent, it means they have the same measurement. So the question mark is equal to 110 degrees. That's it. Key part is, though, make sure you write down the angle relationship. All right, let's go to number 3. This one will be a little bit longer because we have a variable we need to solve for. But let's first think about what angles we're talking about. This time we have angles that are, one of them is outside of the parallel lines and one of them is inside of the parallel lines. When this occurs, the only possible angle relationship that it could be is corresponding. So these are corresponding angles. It cannot be any of the other relationships because all of those require either both angles to be inside of the parallel lines or both angles to be outside of the parallel lines. But when one is inside, one is outside, it has to be corresponding if it's any of the relationships at all. If they're corresponding, that also means that they are congruent. And this time I'll just show you the congruency symbol because you can either write out the word congruent or you can just put the symbol. So again, if they're congruent, well, this 75-degree angle has to be equal to the 11x minus 2 angle. And then we just solve. So I'm going to add 2 to both sides, divide by 11, and I get 7 is equal to x, or x is equal to 7. All right, last one, question 5. All right, so these two angles right here, they are both inside. So we have one up here, one down here. They're both inside, and they're both on the left side. So they're both on the same side of this transversal. They're both on the left side. So these are same side interior angles. Again, you could also say consecutive. That means the same thing. Same side interior angles. Now, in this diagram, they actually look like they're both congruent, right? They look like they're both about 90 degrees, but we can't go just based on looks. We have to go by what the definition says. The definition of same side interior angles says that they are supplementary, not congruent. So they can be congruent, but we can't make that assumption. The only assumption we can make is that they are supplementary. So think about what supplementary means. That means that both angles should add to 180 or sum to 180. So we have 20x plus 5. Let me just make sure I'm reading this correctly. 20x plus 5 plus 24x minus 1 is equal to 180. And then we're just going to solve from there. So I combine my x terms, I get 44x. Combine my constant terms and my integer terms, so I get plus 4. Subtract 4 from both sides. And divide by 44. This one actually comes out quite nicely. X is just equal to 4. Okay, so plenty of other ones for you to try. Focus on writing down that angle relationship, though. Understanding, are the angles corresponding angles? Are they alternate interior, alternate exterior, same side interior, or same side exterior? We need to know those angle relationships inside and out because, again, not only are they going to help us solve problems like this, they're going to help us when we get to the proofs about parallel lines and transversals as well. So enjoy the rest of your day. I look forward to seeing you next video.